Welcome to Firebird Tech. As always, I'm Nick. Today we're going to be talking about recycling one of these, traditional sort of mid-2000s microwave. What can we get out of them? What can you actually use out of something like this? And I'll go through as we go. What can be used and everything else. Now, a disclaimer first up. There are parts inside of this that will kill you on contact. If you do anything out of this video, it is at your own risk. There are capacitors, transformers, everything. There is a lot of parts in here that will kill you on contact if you don't respect them. So, that's hopefully pretty clear to everyone. But again, you're doing anything out of this video at your own risk. Alright. So, what are we planning to get out of one of these? Well, transformers, possibly some relays, some interesting other bits of mechanical gear, glass, etc. Maybe some other power stuff, but we'll have to have a look once we get in there. So, I'm going to whip off this metal shield, and then we'll come back. So now the metal shield is off, we now have a look inside of the business end. Pretty much all microwaves that you'll pull apart, that all their electronics will be on one side. Usually the side with the keypad, because that makes sense. Again, this microwave dates from about 2005, sort of mid-2000s. And that's, if you are looking to recycle one, that's pretty much where I would say that's the golden way. That's the golden era. So 2000 to about 2009 would be where you want to pick one up from. Because they usually still have transformers, microwave oven transformers. They haven't gone completely transformerless like the really new ones. They usually have an old school magnetron as opposed to the newer sort of multi-power level, like 16 wires coming out of the thing. You know, they're a bit more difficult to try to reuse. And the electronics board on these are usually also pretty simple as well. They tend to be, again, you may not be able to use it as it is, but there's nothing stopping you pulling it apart and getting stuff out of it that is useful. So this little board up here, which you can't really see because it's cross-member, there's a little board up here that is a mains filter. What that does is it takes the noise out of the appliance so it doesn't get transmitted down the cable. So that's one thing that you can definitely salvage, and we'll talk about that once we get it out. So we've got the mains filter we can recycle and reuse. We've got one fan at the back, dubious on that. We have a very high voltage capacitor at the bottom, high voltage diodes, high voltage transformer. This will actually have 3 windings to it. A primary winding which will plug into your main supply, be that 220, 240, 110, 120 volts, whatever that is in your country. It'll have a heating filament wire, so that's like typically 3 to 5 volts for the filament inside of the magnetron. And then you'll have a high voltage winding, which is like 2 to 5,000 volts, depending on the wattage of the microwave. In this case, it's looking like it's going to be around about 2.5 kV, given that's a 900 watt microwave. So that's what happens is that high voltage winding, which is this wire right here, comes into the capacitor. There's actually a discharge diode on this as well, and an internal discharge resistor for these high voltage capacitors are always built in. And then that high voltage winding comes out to the magnetron to actually provide the high voltage that actually makes the RF. Essentially, these are an RF charge pump. I'll get into, again, explaining more about how these work once we pull it out. So we're going to engage time lapse and pull this thing apart. So here's a table full of goodies that we got from One Microwave. Come on, Color. Thank you, Color Box. Alright, so we have our mains filter board, which can be used in other, if you put an extension lead on both sides of this, you know, you could probably even just use the original lead. I do recommend that you, like, put this in an enclosure and make it safe, but essentially what you can do is you can use this to silence a noisy appliance. What that essentially means is you go around the house, let's say you have a radio, for example, that's making a hum when it's not tuned into anything, or a surround sound system that's making a hum. Well, you go around the house and you systematically turn off an appliance, you know, turn off the fridge, the freezer, the TV, etc. And you find out what is making that humming noise. And then you plug this thing in line with its power cable. Now these are actually usually pretty well labeled. Line, neutral, live, neutral, you know, input, output. They're pretty well labeled, these typically anyway. My light is not great, but so these are typically well labeled. And essentially about the way they work is you have two inductors in series with both phases, live and neutral. You have a capacitor across that power, a common mode choke, which essentially is a one-to-one transformer that makes the noise from one appear out of phase with the other, and basically that's essentially a noise cancelling filter. Then you have another capacitor across the mains, and then a couple of other little capacitors down here that go from each of the phases to earth. So these only work if you plug them into a protective earth. So bear that in mind. So that's one thing you can get from these. Okay. The next thing you can get is, let's just go around with the motors. So this is a synchronous motor. This is what actually turns your plate of food. That's what these are used for. Typically they have very, very low RPMs, 2, 3, 5, 10 RPM. But it's based on the frequency in which goes into these. In this case, if I put 220 to 240 volts at 50 Hertz into this thing, I get 5 RPM. If I was to stick 220 to 240 volts at 60 Hertz into this thing, I get 6 RPM. That's just the way they work. You just plug mains into them, and this shaft will spin at 5 or 6 RPM, or you know, some derivative of essentially divide by 10 of the mains frequency. So hence it turns your food. So that's something you can use if you need a synchronous motor for something, or a really low RPM motor for something, you know, a turntable or something along those lines. You can probably use it. A whole family of micro switches. These are actually can be used for other things. The limit switch, you can use them as limit switches for, you know, 3D printers and stuff like that. They are a bit like totally overkill for that purpose, because these are actually rated for 1.5 amps or half a horsepower at 125 volts or 250 volts AC. 250 volts AC, it's 0.6 of an amp, because you know double the voltage, half the current. But they're also rated for 0.3 of an amp DC at 250 volts. So you could use these as limit switches, maybe a touch overkill, but you could use these as limit switches. You could use them as, you know, switches for human interface if you wanted to. But they are very useful little micro switches that you can get from these systems. A light bulb and its associated bulb. Because these bulbs go bad so often, they're actually relatively inexpensive. But at least you've got the socket for it, and you could mount this in like a flexible arm for a work light. You know, that's a useful one of these. What's next? So the next is the fan housing and cowling and everything. This one needs a bit of a clean up before it ever be used. But you could make this into a motor cooling fan. You could make this into a desk fan if you're really desperate for a desk fan, or a general, you know, quiet, decent volume fan for something else. So that's just something to think about. These are usually pretty efficient, but again, you have to worry about the fact that you do have open terminals. So you have to make sure that this motor is enclosed inside of a motor housing, or some form of housing that doesn't allow these people to touch these contacts. For that, they actually do include 2 threaded terminals. These are actually threaded in here. No idea what thread they would be, but they're threaded nonetheless. So you could use that as a threaded base. So you could thread this onto like a wall mount or a vent or a window or what have you, and then have this bit insulated with you could paint these terminals with like liquid electrical tape, and then have a fan there and have it as an intake or exhaust fan, whatever you need. And of course it comes with a fan ducting as well, if you need to use that as well. You can probably turn that into the housing for it. So that's the next bit that's been talked about. Next we'll talk about some other small bits that's down here. These are what's known as bimetallic thermal switches. Really fancy term for essentially a switch that turns off or on at a specific temperature. Now, both of these are what's called normally closed. So when these are at room temperature or below their tripping temperature, they're closed. They actually conduct. But when they reach 180 degrees Celsius with this one or 105 degrees C with this one, what happens is they open. There's a little bimetal switch in there. Basically, two strips of metal that sit on top of each other, and one deflects more than the other at different temperatures. And what they can do is they can deflect so much at a given temperature that they actually open the circuit. They can be handy for that. So these are basically thermal safety switches, and pretty much every microwave is going to have at least 2 of them. Sometimes they will have up to like 4 or 6 of them. So that's something you can reuse if you're looking for a safety switch or a thermal switch. They may seem simple, but they can be used for other things. So on to the next things. The main control board. Now this is a part that definitely can't be used in its native state, because all it is a brain box for a microwave. So not that gratefully useful, but can be pulled apart and made extremely useful. This transformer is mains in whatever country you're in. Now in this case it's 240 volts, 50 hertz in, and it has a 16.33 volt RMS output, as well as 2 5.47 volt outputs. So you can make a plus minus 5 volt supply and a plus 12 volt supply out of that transformer alone. Not to mention you have the diodes, the capacitors, even the Zener diodes in there, to make it a very nice regulated supply. It is already built onto this board for you. So you may not be able to use this board as it is. Nothing stopping you pulling it apart, putting it on a prototype PCB and making up your own regulated power supply. Now this one doesn't give you current, unfortunately, but going by the size of the secondary windings, I'd say you wouldn't want to push it past an amp, maybe an amp and a half at most, which is more than enough for what you need. That's something you can use. These relays here, the black and white one that's here, if my color balance would like to cooperate. The black one is a very high current because it actually has the separate terminals. Doesn't even use the PCB for the printed circuit board for those current terminals. So this one here is an OEG, which is basically a rip-off of an Omron switch. So it has a 12 volt DC coil and is rated for 20 amps at 125 volts AC or 17 amps at 250 volts AC. To give you an idea. So that's a really good relay if you want to switch on, quite big mains things like motors and stuff like that. You still want to stub a network across that and everything else. The other relay that's in here, this little white one, it's rated for 3 amps at 250 volts AC or 3 amps at 250 volts AC, and it also has a 12 volt coil. So you need to provide 12 volts to one side of this to make the switch open and close. Nice and simple. A very loud or extremely loud piezo buzzer can also be used for other things. You got a clock crystal in here, the capacitors to go with it, a whole, family of transistors in here that you could use for things. The segmented display could be used if you could reverse engineer it. These typically are static system displays. They're not typically like your very typical 7-segment display. They're not always a 7-segment display. In this case, I think we got lucky, and this is a 7-segment display with you've got basically a 5 cathode or anode 7-segment display. So you've got 1, 2, 3, 4, 5. Yeah, so 1, 2, 3, and 4. The time digits would be, or the digits, the 4 digits that actually display the numbers would be standard 7-segment displays, and then the 5th element would use all the icons. So you'd be turning on all the icons. Stage 1, Stage 2, defrost, lock, like doors locked, timer function, the actual the delineator between hours and minutes. That's also a segment on a 7-segment display. So essentially, you drive this thing like a 7-segment display. Now, not all of these are the same. I have pulled apart one of the microwave, and that was not a standard 7-segment display. So bear in mind with that. They can be non-standard. In this case, we just got lucky, and it is standard. There's a 5-way 7-segment display. But that's basically what you can get off of one control board, one of these control boards. The brain box, again, is so custom that there's no point. They actually do make legitimately one-use microcontrollers that are microwave oven controllers. They serve no other purpose. They cannot be reused. They are purely a microwave oven controller chip. That's all they do. So that's useless. It's not like an Atmel that you can reprogram as an Arduino or a PIC micro that you can reprogram. It is literally a Samsung chip that is specifically designed to be in microwaves. So, sorry, no microcontroller out of this one. Okay, on to the next part. I think we'll talk about these two sort of together, but also separately. This is a high voltage diode, you know, a few kV typically, and what these provide is essentially back run out of it. So this was connected to the capacitor, this high voltage capacitor, which we'll get into in a little bit. This diode essentially allows for that forward current to go somewhere when the microwave is turned off. It's essentially a discharge diode, but that's also comes into point what I'm holding in my hand. This capacitor is essentially the single most dangerous item in this entire set. This is the bit that as I said at the start, there are parts in this machine, in any microwave, that will kill you on contact if you're not sensible with them. This happens to be one of them. This is a 1 microfarad capacitor that is rated at 2100 volts AC, which is what comes out of this transformer. 2100 volts, 2100 volts AC, which means it actually has a peak more like 2300, 2.3 kV, but it's a microfarad. That's enough to stop your heart, no questions asked. This is a very powerful capacitor, and likewise, it actually has a safety discharge resistor in them. If you get an old enough one of these, the safety discharge resistor doesn't exist in them, so bear that in mind. Magnetron will be next. Again, this is another component that I would consider not reusable in its current state. Not unless you need a 2450 megahertz RF transmitter. Otherwise, they're not really that useful. What is useful in these, as I keep pulling metal off of this that may make it obvious, is there's two very big ring magnets in these, focusing ring magnets, which can be used to make toroidal transformers, or this really powerful fridge magnets if you want to keep, you know, a ream of paper on your fridge. Otherwise, they're not extremely useful in their current state. But these essentially, what you do is you provide 3 volts DC to them, and that heats up a filament, which is that purple thing at the end, which you may be able to see. That's the thing you don't want to touch because it contains beryllium oxide, which is not good to touch. So that's one part of this. You have to heat up the filament previously. You have to heat up the filament, which is also part of this transformer. But that's one part of this. The second part is the high voltage, the 2100 volts that we talked about before. That provides that essentially provides a very high voltage 50-60 hertz signal to this. This then amplifies that and also amplifies it in terms of frequency, so it multiplies the frequency up using resonance. You know, classic wine glass trick. You tap the wine glass and it makes a noise. You can do the same thing with RF, and that's what the microwave does. It takes that 50 hertz in, resonates it inside a cavity. That cavity produces 2450 megahertz, 2.45 gigahertz, to this nozzle, which then goes through into the microwave to heat your food. So that's one way that this is essentially what these are used for. So yeah, that's essentially how a microwave oven magnetron works. So bear that in mind. These are, again, another part that could potentially kill you on contact, but just be very mindful of that. That there is beryllium in the tip of these, which makes them a bit if you want to pull them apart. I strongly suggest wearing you know, full PPE, so eyes, ears, well, maybe not ears, but definitely eyes and mouth, and definitely hands as well. If you've got nitrile gloves, I'd wear them when you're pulling one of these apart, because this is not just a stem. This is actually a core of beryllium that runs down the full length of this magnetron all the way into the cavity. So if you break that and you breathe it in, you're basically dead within 6 months. So you really don't want to breathe in beryllium oxide or any beryllium products. So bear that in mind when we are talking about this sort of stuff. So not necessarily useful in its state as it sits, but definitely useful if you want to pull it apart and have a look inside of what actually one of these does. It's actually a good Panasonic one too. So now we get on to the microwave oven transformer itself. So this has quite a few windings in it. So you have a mains winding in, you have a heater winding out, and then you have your high voltage. What's inside? People may ask, well, what's inside this big white thing? That's just a high voltage fuse. In this case, 5000 volt rated at 0.75 of an amp. So 3/4 of an amp rated. So that can give you an idea that it's very high voltage and significantly enough current to warrant a 3/4 of an amp fuse. So yeah, this is the other part that can definitely kill you on contact if you're not careful with them. So bear that in mind. So this film wiring is usually going to be about 3 to 4 volts AC, which is all this magnetron needs to get up and running. So that's essentially what these are. You can modify it. There's so many videos on YouTube itself of modifying these to be spot welders, to be arc welders, whatever you want, and of course having fun with 5,000 volts or 2,100 volts AC at low-ish currents. I wouldn't say safe currents, definitely not safe currents, but low enough currents to have a bit of fun. But yeah, again, this is another part that will kill you on contact if you do not respect it. Alright, on to the last 2 bits. We'll go for this one first. This is the grid that's out of the actual front of the microwave. Now most people go, well, what's the use of this thing? Well, essentially it is a Faraday cage. So... Alright, before my iPad had a bit of a tizzy fit, we'll keep talking about this. So, these grids, well, if you peel off this film, what you can do is you can actually turn this into a vacuum former bed. So these actually have a really nice thick wall around the whole thing, and you can actually mount that to, let's say, another bit of metal, like weld it around the seams, and making a vacuum chamber. And you could have your heaters above it, and you put it in your plastic holder and make a vacuum former out of this. Not a very big bed, but a vacuum former nonetheless. So that's something that you could use this one for, is vacuum forming bed, if you can find heating elements. And again, if you found one of these that was like a combinational oven, that wasn't just a microwave, but had like convection functions and other functions, well, you can get heating elements and basically make yourself a vacuum former. All you need is a vacuum pump out of these. So the last part to talk about is actually the glass front. These are not necessarily useful as an actual window or anything like that because of how big the mask is on these, but you could use it as like a nice flat surface once you clean it up. So like you could put sandpaper on this and make up a sanding block or a sanding system for these. Just a quick example. Excuse me whilst I turn off the fan. Is you can actually glue sandpaper down to these to make a really flat surface to sand on. So instead of trying to hold the sandpaper and try to get a flat surface that way, you just glue it down to, or double-sided tape it even, down to a piece of glass, and presto, you have a nice big sanding bed. So these are actually, that's a use for one of these. I'd probably pick the side that doesn't have the masking on it, because that can have a bit of a lip to it, but that is definitely a use for one of these. So, now we've talked about all the bits, we'll go back to the outro. So, that's everything you can salvage from a typical microwave. Is it a lot? Yeah. Again, if you get convection ovens and that sort of stuff thrown in, they'll typically have another fan, another heating element, that sort of stuff. And pretty much you can turn those into vacuum formers. You've got a whole bunch of electronics you can desolder and make into awesome things. So bear that in mind. You can do a lot of stuff with a microwave. So if you are thinking about doing this, again, I'll reiterate the disclaimer at the start. There are parts inside of this machine, inside any microwave. The minute you take off the case and it's live, or even turned off for a few minutes, they're not safe. If you do plan to take apart a microwave and you're unsure about it, leave it somewhere unplugged, untouched for about a couple of days, maybe a week, before you think about pulling it apart, to make sure that particularly this capacitor is discharged. That's the biggest thing you have to worry about. But also to make sure that nothing else is at mains potential or a high voltage potential. So without further ado, I'm Nick from Firebird Tech. Thank you for watching. Do the usual shenanigans of liking, subscribing, etc. If you do wish to contribute to the channel, there is a PayPal donation link below. So without further ado, thank you all for watching, and I'll see you in the next one.